So, good morning. Today I am going to start the chapter solubility. Okay, under solubility, we have to cover many topics. So, first of all, the definition of solubility and what are the factors affecting solubility of drug and about Raoult's law, critical solution temperature, distribution law. Okay, so today we'll start the introduction portion. Okay, so first of all, we'll look the definition of solubility. What is solubility? What is solubility? In simple terms, we can tell the amount of solute that can dissolve in a solvent. Okay, but as per the definition, solubility is the amount of solute to dissolve in a solvent to form a homogeneous solution. That is the ability of a solute to get dissolved in a solvent to form a homogeneous solution. The resulting solution should be homogeneous. There should not be any barrier or layers formed between the solute and the solvent. Such types of solutions are said to be soluble and we call as solubility. The amount of solute that get dissolved in a solvent to form a homogeneous mixture at a particular temperature and pressure. So this is the definition of solubility. So it can be expressed in two ways, both quantitatively as well as qualitatively. Okay, so what do you mean by quantitatively? Quantitative, what is that? Based on the quantity, that is number. That is the concentration of solute, how much solute we are adding in a solvent in quantitative forms. That is said to be quantitative expression of solubility. And what is qualitatively, how solubility can be defined? Qualitatively. Qualitative. You're doing qualitative analysis in the lab. So what you're doing? You're observing the color reactions and you're telling the given compound or sample is said to be this, so and so. Like that wise in in solubility also we can tell like that. The solute when we add, for example, sugar in water, we are adding sugar. Whether it gets easily dissolved or do not dissolve easily. What is that sugar? What is the effect of sugar in water? Easily dissolved. So we are seeing it, we are observing it. So we can express it qualitatively. So I am telling simple that the solubility can be expressed both qualitatively and quantitatively. Okay. So quantitatively, the solubility is defined as concentration of solute in a solution. Quantitative, that is the number, the concentration. And qualitatively, solubility is defined as spontaneous interaction of two or more components. That is spontaneous interaction of solute with a solvent to form a solution. Clear? What is solubility and how it is defined in quantitative as well as qualitative terms. Clear? Okay. Next, the principle like dissolves like helps to predict solubility. That is, from the name itself, it is clear. Like dissolves like means what? The solute and the solvent component should be similar in nature. That is, if the solute is polar, the solvent should be also in polar. Okay, if the solute and solvent both are of same nature, the solute get easily dissolved in the solvent. That principle is known as like dissolves like. Okay, clear? Okay. Next, types of solution. How many types? Saturated, unsaturated and supersaturated. What is saturated solution? Saturated, something is getting saturated means it has reached its maximum limit or maximum level. So furthermore, no more solute can be added. Okay, that type of solution is called saturated solution. And what about unsaturated solution? The opposite of saturated. What is that? Unsaturated solution means solution containing the solute amount less than that of saturated amount. So in this type of solution, in unsaturated type of solution, there is a chance that we can add more number of solute because it still has space to add more number of solute. And next, super saturated solution. What is super saturated? Saturation means maximum level. Super saturation means beyond the maximum level of solute will be contained in super saturated types of solution. Since this type of solution contains more the number of solute than that is present in saturated level, that solute, extra solute particles get precipitated out or it get crystallized out. Okay, so these are the three types of solutions: saturated, unsaturated and supersaturated. Next, solubility expression. What is solubility expression? It is a quantitative measure of amount of solute that can be dissolved in a given solvent at a specified temperature to form a saturated solution. Okay, generally the solubility expression is also giving in terms of the definition, that is the amount, okay, the maximum amount of solute that can be present in a given solution to form a saturated solution at a given temperature and pressure. That is how many parts of solvent is required to dissolve one part of the solute. Okay, it is normally expressed as grams of solute per 100 grams of solvent or grams of solute per 100 ml of the solvent. It is also given in terms like molarity, molality, weight by volume, weight by weight, volume by volume, etc. And also in terms of parts per million. Okay, see this table. As I already told earlier, that in solubility expression, we are looking how many parts of solvent is required to dissolve one part of the solute. Based on that, we are giving different solubility ranges. Okay, see the descriptive terms like very soluble, freely soluble, soluble, sparingly soluble, slightly soluble, very slightly soluble, and practically insoluble. When will we say that the given solution is very soluble? If that solution, in that solution, just less than one part of solvent is required to dissolve, how many part of solute? One part of the solute. Okay, see the solubility range. How much? Greater than 1000. See the next one, freely soluble. In freely soluble, within the range 1 to 10. Within that range, we read the solvent parts to dissolve one part of the solute. Such types of solutions are called freely soluble, and the solubility range of that solution will be 100 to 1000. Next, soluble. For soluble solution, we require the solvent part between 10 to 30. See, the numbers are increasing. So you can see the here descriptive terms what the solubility is decreasing, right? Last you see the column, it is practically insoluble. Means you require more than 10,000 parts of solvent just to dissolve one part of solute. The solvent parts are increasing. So the solubility of that solution is decreasing. So what will be the solubility range? Less than 0.1. You can see the parts of solvent that is required to dissolve one part of solute is increasing. So that means the solubility is decreasing and also the solubility range is also decreasing. This table is very important. Okay. And what about sparingly soluble solution? The solvent part between 30 to 100 is required. And slightly soluble from 100 to 1000. Very slightly soluble 1000 to 10,000. And practically insoluble more than 10,000. Okay. I think these terms you are familiar, right? Okay. Molarity. The solubility is also expressed commonly in molarity, molality, percentage weight by weight, percentage volume by volume, percentage weight by volume. So what is molarity? That is moles of solute expressed in volume or mass. Volume of solvent or solution. Volume of solution in liters. The equation is very important. Okay. That is number of moles of solute dissolved per liter of the solution. Okay, next molality. What is molality? Moles of the solute per mass of the solvent. Okay, in which unit? Mass of the solvent in grams? No, in kilogram, the standard unit. Next, percentage weight by weight. Percentage W by W means the numerator as well as the denominator. Both that part consists of what? Mass related terms. Because see the unit, percentage weight by weight. Both the upper and lower part should be in grams. Okay, that is mass of the solute by mass of the solution into 100. Next, percentage volume by volume. The upper and lower part should be both volume based. Okay, volume of the solute in milliliters divided by volume of solution into 100. Next term, percentage weight by volume. Numerator part, what is it? W means mass or volume related, mass related. And what about the denominator? Volume related. Okay, so mass of the solute in grams whole divided by volume of solution in ml, milliliters into 100. Okay, the terms are clear. Next, mechanism of solute-solvent interaction. As I told in the starting of the chapter, how the solute get easily dissolved in a solvent. If the solute and solvent both possess similar stability or intermolecular forces. That means like dissolves like. Polar solutes easily dissolves in polar solvent and non-polar solutes easily dissolves in non-polar solvent. Okay, so this mechanism of solute-solvent interaction, it is only based on the principle what? Like dissolves like. Next, factors affecting solubility of drug. There are so many factors that affect solubility of drug like temperature, pressure, particle size, surface area and polymorphism, rate of solution, etc. Okay, so first we will deal with temperature. How the temperature affect the solubility of drug. That is mainly two ways. If the process is endothermic, okay, endothermic means what? Whether heat is absorbed or heat is released. Heat is absorbed. Okay. In endothermic process, solubility increases with temperature. Okay. And in exothermic process means what? Exothermic, heat is liberated or released. Endothermic process, both are directly proportional, both solubility and temperature. In exothermic process, the temperature and solubility are inversely proportional. Okay, example for endothermic reaction is potassium nitrate, energy absorbed during potassium nitrate, and examples for exothermic reaction is energy released during calcium hydroxide, dissolution of calcium hydroxide. Okay, are you clear? Topics are clear? Should I want to repeat again? Clear. Okay, the next topic we'll look in next classes. Okay, thank you.